All right. Actually, I watched my previous video and I don't think it will be a good fit, so I just make a new video for you guys. All right, so from last class, we talked about how to create a decision tree, right? So let's review a little bit. So in the last class, we used this housing data, right? And then we put a table to describe all of these variables. So we have the total value as my target variable, right? And then we say tax is still a target variable, but tax is just a repeated information with the total value. It's just a tax rate times the total value. So we just exclude it. So the variables 0 will be the rejected, right? And then all other variables, it doesn't matter this variable is a quantitative variable or a categorical variable, we can always use them as a prediction for the total value, right? So actually you can see that from last square feet until the fair places, they are all quantitative variables. But for the remodel, is actually when the house was remodeled, recent, old, or new. So actually this variable is a categorical variable, right? So in the decision tree, we don't need to worry about this variable is a quantitative variable or a categorical variable. So all of them can be considered as input variables. All right, and then next we say we use this data set to create a simple decision tree first. We just use the two variables, the gross area and number of floors, right? So then we just look at this data set. And then we go to analyze, and then we use the predictive modeling and partition for the decision tree, right? And then what? And then we say the total value should be my response variable. And then here, let's create a very simple one. Just to use two variables, two input variables, gross area and number of floors at the beginning, right? And then click OK. So that we have a default screen, right? So we say these points are each house price, right? So we can see that most of the houses have the house price at this level. It's about $400,000, right? And then in default, you will have a table. We call this is the summary table. So from this table, you have the number of observations in your data set, right? And also tells you number of splays. So right now, we don't have any splays now. So you have a kind of a summary table with all the observations, right? So that would be a whole observations. So then we can split for our first time, our second time, and third time, so that we have kind of a tree, right? So we call this all rows table. This one is the root of the tree. And then we have different branches, different directions, right? Different subgroups until the end. Here we call these are the end nodes. What are the end nodes? End nodes will be the leaf that you don't have any further subgroups. So how many end nodes do we have? Actually, 1, 2, 3, 4. So we have 4 end nodes or 4 leaves. All right. And then based on this decision tree, we did a practice, right? So in the chapter note, I just make a screenshot, right? So here we say, if I have a home with 2 floors, and gross area of 4,000 square feet, then what is the predicted house price based on this decision tree, right? So then we say, based on this decision tree, we start from the root until the leaf, so we go this direction to make the predictions. So first step, it is divided into 2 subgroups based on the gross area less than 3667 or larger equals to 3667. So which one it belongs to. So actually, we have the gross area is 4,000 square feet. So of course, it is larger equals to 3667, right? So the house belongs to this subgroup. And then we can find out that we don't have any further subgroups for this subgroup, right? So then actually you can just make the prediction based on this subgroup, right? So that means we have all the houses share the same characteristic that the gross area is larger or equals to 3667. So then for this kind of houses, what is the mean? What is the average house price? That would be this much, right? So then what is the prediction for this house? That would be 542, right? 542,000. It is in thousand, right? So then 038,100, right? Okay, so then we have this prediction, even though we have the information for how many floors, but since this is a simple decision tree, we don't have any subgroups about describing how many floors do we have, right? So then we don't use that information because we don't have that subgroup anymore. All right, and then for the next practice, we say we want to make an estimate value for the single-story home with 2,000 square feet. So then how we can make the predictions? We say we still start from the beginning, right? And then we decide which subgroup this house belongs to, right? So it has 2,000 square feet for the gross area, right? So of course it is in this subgroup. Is this the end? No, right? So we go to the next two subgroups. Again, it is based on the gross area is less than 2,595 or larger or equals to 2,595. So of course 2,000 square feet is in this group, right? Is this the end? No, we need to go to two more subgroups based on now is based on the floors, right? So now it is a single story home, so the floors will be 1, so less than 2, right? So now do we have any more subgroups? No, so then we can stop here. Our prediction would be this much, right? So that would be $305,000 and $810, right? So that would be our predictions. All right, so then we say, let's make a summary, right? So we say what? We say to make predictions, we start from the root of the tree, right? And then what? And then we follow the tree until the end nodes, and we can use the mean of that group to make predictions. Say to make the prediction of the new observation. Right? Okay, so this is the prediction. Now, reversely, right? So for example, if I have this decision tree and I want you to describe the characteristics of the cheapest house, how you can describe that? So first we can find out which kind of houses has the lowest house price, right? So which one? We say for this subgroup we have this mean, this subgroup we have this mean, this subgroup we have that, we have those, right? So which kind of house has the lowest house price? That will be this subgroup, right? And then how to describe this subgroup? We say first it should have number of floors less than 2. Is that all? No, because what? Because this subgroup comes from this subgroup, right? So of course this subgroup also need to make sure the gross area is also less than 2,595, right? So gross area, it should be less than 2,595. Is there anything else? Yes, right? So actually this subgroup comes from the upper level, right? So also we need to make sure the gross area is also less than 3667. Is that all? So this is the subgroup of all the houses, right? So that would be it. But now you can see that we have two kind of the conditions for the gross area, right? So then actually we can put them together, right? We can combine them together. So then if the gross area should be less than 2595 and the gross area should be less than 3667, if you put them together, what will be that? So that would be, of course, the first condition is still floors less than 2. And then once we combine these two, that means you need to make sure the gross area should be less than 2595, right? Because if the gross area is already less than 2595, then the gross area, of course, will be less than 3667, right? So then if you combine them together, that means you just have one condition for the gross area, which is less than 2595, right? So then we say the cheapest house, right? The house is, say this, right? 259. It's not easy to type it, right? So then we say the houses with number 4 is less than 2 and gross area less than that has, let's say, have the lowest have the lowest price on average, right? Okay, so that would be how to use the decision tree to describe one kind of house. All right, so then let's continue, right? So next step, actually what we did is now we just have 3 splits, right? And then you can see the R square is quite low. And then we expect that if we have more splits, of course, your predictions will be more accurate. So then let's keep splitting it, right? So for example, split, split, split. We have the tree is growing up, right? Getting bigger and bigger and bigger, bigger, right? So for example, we stopped here. Now we have 14 splits. All right, and then in our chapter note, I just make a screenshot of this big tree with 14 splits, right? So then for the same house, right? So for example, for this one, right? If for the same house we have 2 floors and then the gross area is 4,000 square feet, then how you can make the predictions. So again, making prediction, we start from the root until the end nodes, right? Okay, and then we say we start from all the observations together divided into 2 subgroups. So now we have the gross area is 4,000. So that would be larger equals to 3667, right? And then continue because it has further 2 subgroups. So 4,000 is less than 4,999, right? And not stop because we have 2 more subgroups based on the gross area again. So 4,000, again, it is less than 4104, right? And then next, we have 2 more subgroups based on the number of 4s. Now we have number of 4s equals to 2. So of course that would be 4s larger equals to 2, right? So now based on this bigger tree, we have a more accurate prediction for this house, right? So that would be 492,000 and $30, right? So that would be the prediction for this house based on this bigger tree, right? So from this smaller tree, we have this prediction. Based on the bigger tree, we have this prediction. You can see that we have quite large difference, right? So then, of course, we say this one is more accurate, then can you keep splitting the tree? For example, you split the tree for 5,000 times. Of course, we don't want to do that, right? So then we say we want to find a best stopping point, right? So we have a kind of a smaller tree, but at the same time, we have the most accurate predictions, right? So then we say we want to find the best point, right? So how to find the best point? It's our time to talk about the validation, right? So if you still remember, we say at the end of each data analysis, we want to use another set to validate our model, to test our model, to see, okay, whether our prediction is accurate or not, right? So then we say at the beginning of your sample, right? So first we have a sample, right? I want to divide this sample into two parts. The first part we call it is the training set. Right. Another part is called the validation set. Right, and then we say we use the training set to create our model. In this case, we say we use the training set to create this decision tree. And then we use another set from the sample to test whether we have a good prediction. All right, okay, so then here in the original data set, I create another column. We call it is the validation column. Right, so this column is created to tell, okay, I want to include this observation into the validation set. I want to include this observation into the training set, right? So then if you look at the distribution of this variable, validation variable, you can see that this variable is a categorical variable. We totally have two, sorry, right? We have two categories, right? So one is training set, one is in the validation set, right? So I kind of want to set 50-50 of them, right? So then I say I want to use this column to let JUMP decide where is the best point to stop. All right, so then let's try it. So analyze, predictive modeling, and partition. Right, let's keep the easy case, right? Total value would still be my target variable, right? And then I still want to focus on the two variables. But now here is the difference. See here, right? I have a validation option. Right, so here is time for us to put the validation into this space to tell the JUMP, okay, I want to use this validation setting for validation. All right, so then click OK. So this is the default screen. You can see exactly the same, but you can see a different button. All right, so this button just came out. Right, so we have an actual one called Go. So what is this Go button? Actually, from here, you can see that the summary table is a little bit different now, right? So you have two sets, training set and validation set. And then from here, you can see how many of them in the training set, how many of them in the validation set. All right, if I click Go, you will have a summary table with the R squares for each set, right? And then you will have a split history come with it. So what does this plot tell you, right? So you can see that the validation data is in red, right? So then we have a red curve. That means the other blue curve is for the training set, right? So here you can see, you can consider the y-axis, which is the r square for both of these two sets. So it's kind of a similar idea with the r square and adjusted r square. So we say for the training set, of course, if you have more and more splits, then the r square will be keep growing, keep growing, keep growing, right? Even though one split is not that useful for prediction, right? But since you keep splitting it, then the subgroup will be more pure, then the r square will always increase, right, for the training set. And then for the validation set, we say at the beginning, the validation set r square will keep improving, right? Keep increasing, increase, increase, increase until a point. Remember, validation set is for validate our predictions. So then actually from somewhere, the r square for the validation set start to drop, begin to decrease. That means from this point, the predictions will not be as accurate as before, or the split is not that useful anymore, right? So then actually based on the validation set, we can tell where to stop. So where to stop, actually from this summary table, you can see that we only need 26 splits. After the 26 splits, the splits is not useful, right? It will not help with the predictions, and your tree is getting bigger, which is not that useful, right? So actually here the validation set tell us where is our best stopping point. All right, so then now we know we need 26 splits. Do we need to manually get the decision tree? Actually, no, right? In default, it doesn't show us the tree. So then we go to this red triangle, and here is the display option, right? From these options, you can ask the jump to show the tree for us, right? Show tree. All right, then you can see that, okay, here is the detailed tree with 26 splits, which is our best decision tree. All right, okay, and then here, I want to see another thing is, if you go to this red triangle, and there is another option called the column contribution. So what is this one? So if you look at this column contribution table, you can see that which variable is more useful, which variable provides more contribution to the prediction. Which one is actually gross area, right? So from this column contribution, it says 85.91% of the contribution is from the gross area, right? So 23 splits are based on gross area, and only 3 splits are based on the number of fours, right? So it only have 14.09 contribution to the decision tree. All right, so now based on this decision tree, we can make our best prediction for those two houses, right? So to save time, we don't do that practice again. You can try that by yourselves. All right, so now we have this split history and column contributions, right? But remember at the beginning, we have all of these variables, right? To make things simple, we just tried 2 variables, but actually what you can do, total value is our response variable, right? And then I can include all the possible input variables. It doesn't matter this input variable is a quantitative variable or a categorical variable. I don't need to care about that because the decision tree is not based on our calculation. It's not based on our multiple regression, right? So then it's based on the partitioning, right? So then I can put all of them, even though remodel is a categorical variable, it doesn't matter, right? So then put all of the input variables here, and then remember to put validation goes to validation, right? So that jump can give us a best stopping point. Then click OK, right? So what should we do next? We say go, right? Okay, so then from here, what you can have, you can see that now if we consider all the variables, all the available input variables, how many splits do we need? It's actually 91 splits is needed, right? Okay, and then you can see that the validation curve, which is the red one, right, keep increasing when we keep splitting the data set until the 91 split, then the R-squares start to drop, right? So that would be the best decision tree we can get. All right, so now the problem is, okay, I can still ask the jump to show the tree, but now you can expect that the tree will be very large, right? So then if I want to show the tree, can you just make the screenshot for every part? It is not possible, or it is very hard, right? So then we want to save this tree, right? So normally I want to save this tree together with the split history and also column contribution, right? So then I want to save the whole output together, right? So then what you can do, you can go to the file, right, and then export, right, and then normally we want to export as the image so that you can make it bigger and smaller, zoom in or zoom out as what you want, right, and then next, and then you can save whatever or whenever you like it. All right, and then you can have this kind of picture, right, and then you can just make it larger as much as you want, right, and then you can also look at each part in more details, right, and then you have the split history and column contribution table. All right, so now let's look at this column contribution table. Which variables are really used here? So actually, the first variable, which is living area, has the most contribution to the decision tree, right? 10 of them, right? And next one, the lot square foot, we have 22 splits based on lot square foot, but the contribution is much smaller, right? Because maybe it's just because the difference is not that significant, right? So then your contribution is not as that much, even though you have more splits based on the lot square foot, right? And then you can see they are ordered, right? It's very easy to see. And then until the end, which variable is totally not used? It's actually the chicken, right? Sorry, the kitchen, right? Because the kitchen has 0 contribution, right? So then we say we only used these variables and kitchen is not important for our prediction, right? So actually based on this column contribution, in the future, if you want to create a multiple regression, like what you did in the project 2, is this helpful? Yes, it is quite helpful, right? It will tell you which variable is the most important variable, which variable should be put into your regression, right? So sometimes when we have a lot of variable available and then I want to create a multiple regression like in your project 2, then I want to create a decision tree first and look at the column contribution to see, okay, which variable should be put into my regression, right? So actually these methods can help each other. All right, so this is the way how you save your output. All right, and then we are done with the regression tree, right? But remember we have another kind of tree, right? So we say when we try to introduce the decision tree, we say if your response variable is a quantitative variable, then we call this is the regression tree, right? So actually we are dealing with the regression tree. But the other case is we can also create a decision tree based on a qualitative response. That means your response variable is a categorical variable. Then we call it is the classification tree. All right, so then let's try that case. We say, okay, now I will release that to you. All right, so here we have a total value, right? So this is a target variable, right? I just have the detailed house price. But what if I don't have this variable? I don't have this variable. In another case, when I record the house price, I just record it as this house is an expensive house or a cheap house, right? So we say if this house value is larger than 500, right, $500,000, then I just say, okay, this house is a expensive house, and then I just record it as 1. Right? The other case, if the value of the house is less than 500 or less equals to 500, then I consider this is kind of a cheap house. All right, and then I just record it as 0. So that means for this response variable, you can see from the distribution of this variable, right? So you can see that a lot of houses are considered as cheap houses, right? So only how many of them? Only 731 of them are considered as expensive houses, right? Okay, so then we say if I want to use this kind of, or I just have this kind of categorical response variable, may I still create the decision tree? Just like in class when I draw the circles and axes, right? How I can separate them into different groups, right? So then we can still do that, right? Predictive modeling, partition, right? Okay, and then now I don't have that total value as the quantitative variable, but now I have the target variable as a categorical variable, right? It doesn't matter, right? The decision tree can deal with that, right? And then let's continue to use all of these input variables into X, right? And remember to put validation into validation so that I know where to stop. All right, and then click OK. Okay, things kind of different, right? And then we still have the go button, but we have the color points here, right? So don't care about this color point for now, right? Click go. All right, so that means now how many splits do we really need for this kind of response variable? So actually, we just need 9 of them, right? Okay, and then from the plot, you can also see that at the beginning, the R square for the validation set is keep increasing. From some point, it starts to decrease, right? So which point? 9 splits, right? And then you have this decision tree. What's the difference? First, it is colorful, right? So then we have 2 colors. One is the red one, the other one is blue. So what are they? Right, to show what are they, actually you can go to this red triangle, display options, and then I want to show the counts, right? So remember, when we have the categorical variable, then we don't have the mean or the standard deviations, we have their counts, right? So then show split count. If I ask the jump to show the split counts, then for each subgroup or each block, you can see what are these colors, right? So actually you can see that what is the red color is actually for 0. That means for cheap houses, right? How many of them? In the whole data set, we have these cheap houses, right? And then we have ones as the blue, which is 383 of them. 383 houses are expensive houses. All right. Okay, and then what? And then kind of the same idea, right? So all the houses are divided into two subgroups based on the living area, right? And then each subgroup is divided into two more subgroups based on living area again. And then next one for this branch, you have gross area, gross area. Next one is based on this subgroup is based on the fireplaces. This subgroup is divided into two subgroups based on the number of foot baths, right? So then you totally have 9 space, right? And then I want to show the column contributions too, right? So now, if our response is a categorical variable, that means I only want to make a prediction about this house is a expensive house or cheap house, right? And then which variables are really used? It's actually 1, 2, 3, 4, 5, 6, 7, right? So only 7 variables are really used, and the other 5 of them just have 0 contributions, right? So that means none of them is based on these 5 observations. All right, and then actually we still want to make predictions, right? So for example, I have a new house. I still want to know this house is a expensive house or a cheap house, right? The value is larger than 500 or less than 500, right? So then how we can make the prediction based on this classification tree? Let's make an example. Right, so first I need to have a tree. I need to have a house. Right, so then let me find a space. All right, so for example, let's try to describe a house. Right, a house with, let's say I have 2 floors. Gross area, let's say 4,000 square feet. Anything else? Let's say 2 bedroom, 2 bedroom. Anything else? Let's say 1 fireplace. Which variables are really used? Let's see. Living area, right? So let's say living area. How much? It doesn't matter. Let's make up one, right? Let's say 3500, and the other variables. Lot square feet, gross area, number of rooms, year built, fireplace, bathroom. So bathroom, 2 baths, 2 bedroom. Anything else? How many rooms? Okay, how many rooms? Let's say totally, let's say 5 rooms. Let's try to describe a house with all of these characteristics. Year built. Okay, let's say built in 1990. All right, and anything else? Bad memory. Living area, lot square feet, gross area. So that would be gross area and lot area. Let's say 800. I don't know. All right, let's just make up this house. All right, so now for this house, I want to make a prediction. All right, so then we say, let's go through this decision tree. Right, so first, all the houses are divided into two subgroups based on the living area. Right, so what living area do we have? Living area is 3500. Right, so which one? This one. Right, okay, and then next is based on the living area again, right? So it's based on larger equals to that or less equals to that. Sorry, living area is 3500, right? So that would be larger equals to that, right? So larger equals to 2144. Okay, and then this subgroup based on the living area again. So 3500 is based on is in this subgroup, right? And then two more subgroups based on the gross area. So we have the gross area is 4,000, right? So then gross area goes to here. And then how many bathrooms do we have? Okay, so we have 2 bathrooms. So that would be in this subgroup, right? Okay, so now is our time to make the prediction. And then you can see that our house falls in this subgroup. Then how we can make the prediction? We say now our target variable is about this house is a expensive one or cheap one, right? So then you can see from here, we don't have the mean or standard deviation, but we have how many cheap houses in here? 13 of them, right? Okay, how many expensive houses here? 53 of them, right? And then you can have the corresponding probability. It says 20% of the chance that this house is a cheap house and 79% of the houses are the expensive houses, right? And then our house is in this subgroup. So then we say, since the probability for 1 is much higher than 0, so that means we have larger chance to say this house is a expensive house. That's it. So, all right, so that is the way how we make the prediction based on a classification tree. Right, so let's make a summary here. Say if we have a classification tree, then we still start from the root of the tree, right, and follow it until the end node, right, and then what? Then based on end node, actually just one, right, and then based on this end node, what's wrong with that? Okay. And then based on this end node, we look at the probabilities, right, for each category and make the prediction based on the probabilities. Right, is that clear? All right, so this is how we make the predictions. Then next, let's see how we can describe each category. Right, so for example, based on this decision tree, which subgroup describe the expensive houses? the most expensive houses? Think about it. How we can choose each subgroup, which subgroup contain the most expensive houses. Do we look at the probabilities and compare them within each subgroup? Actually, no, because these probabilities are conditional probabilities, just about this subgroup. You cannot compare the probabilities across each subgroup, right? So here, what do we say? We look at the counts. That means, okay, from these subgroups, how many expensive houses are in this subgroup? 174 of them, right? In this subgroup, how many of them? Only 19 of them, right? This one, 53 of them. This one, 15 of them. 14, 46, 39, 11, 12. And the last one, actually in this subgroup, 0. Right? So then which subgroup contain the most expensive houses? That would be the first subgroup, right? So actually we look at the counts instead of the probabilities, right? So don't look at the probabilities, right? So then let's make another summary, right? To describe the characteristics of each kind of observations, we look at the counts and the one and the subgroup with the most counts will be, let's say, the most ones will be the one to describe the most expensive right? Okay, so then based on that subgroup, okay, now you choose which one is the most expensive house, this one, right? So then how to describe it? That means for this kind of house, you need to make sure the fireplace is larger equals to 1. The gross area should be larger equals to 4322, right? Living area should be larger equals to that. And also you need to make sure the living area is also larger than 2144. And then that's all, right? And then you need to describe all of them. And then you will have the same problem. You have two conditions for living area, how to combine them. It is larger than 2144 or larger than 2352. You say that would be living area is larger equals to 2,352 because if it is already larger than 2,352, that would be also satisfy this one larger than 2144, right? So then this kind of house has living area larger equals to 2,352 and gross area larger equals to 4,322 and fireplaces need to be larger equals to 1. All right, okay, so that would be how to use the classification tree to make the predictions and how to describe each category. All right, okay, and then actually we just have one more thing to do. All right, so we say in the original data set, this validation column is given to you, right? But if this validation set is not given to you, right? So for example, I don't have this column, right? Then how you can create this validation column by yourselves? You can go to Analyze, right? Still predictive modeling, Right, instead of partition, here is another option called Make Validation Column. Right, so if you click that, that means now here they are all optional based on different ways to choose this validation set, right? But now we just want to randomly choose the observations into different sets, right? So here you don't need to do anything, just click OK. All right, and then here is the space that you want to create the percentage for each set. Right? In default, we say we want to put more observations in the training set and less observations in the validation set. So in default, we have 0.75, or we say 75% of the observations in this sample. I want to put them into the training set. The other 25% of them, I want to put them into the validation set. All right, and then click Go. And then you just have a new validation set, right? Validation column. You can use it to let the jump know where to stop. All right, okay, and another way is, actually I don't suggest, but this is an easy way. All right, so normally we say if, okay, for example, this is the target variable, right? And then we have all of these input variable. And then if I don't have this validation set, I can, here, I can input or enter a validation portion. For example, I want to put 20% of the data set into the validation set. All right, and then I can click OK. So then I can still have the Go, even though I didn't put the validation column into the validation space. I can still have this result. Right, but the problem is if you do this, that means every time you do this partition or you want to create a decision tree, then the jump will just randomly assign 25% observations into the validation set. That means every time you will have a different result because every observation is randomly assigned. Right? Then you cannot have a repeated or the same result if you want to try one more time. So I don't suggest this this way. All right, so in the future, if you have created your validation set, make sure here is 0. All right, you don't want to assign any more validation sets. All right, so my suggestion is to create the validation set first so that every time you have this data analysis, then you have the same decision tree come out, right? That would be easier to make sure your result is consistent. All right, so that will be all for the decision tree part. But remember, you have your data analysis coming, right? So then I want to show you something about your data analysis. Sorry for waiting. Alright, so data analysis 3 is still based on your housing data, right? The one you are familiar with. And then the first question, I want you to do some descriptive analysis, right? Try to get a summary, try to understand the variables. Right, so then the first question, I ask you to explore the data by using analyze distribution for all the possible input variables. Right, so here when we say input variables, we don't need to think about this variable is a categorical variable or a quantitative variable because we are doing the decision tree. So that means all the variables can be used as predictors can be considered as input variables, right? And then I want to know that which or here the question is how many input variables have missing observations, right? So how I can figure out that? Let's just use this as the example. Right, so in this data set, I don't have any missing values. Let's just delete several of them. For example, something like this. All right, and then I want to know which input variables have the missing value. So of course, I want to go to Analyze and Distribution for all of these input variables, right? So all of these are input variables. Go to here and then click OK. So then you will have the distributions, right? Still remember what you did in the data analysis 2 for simple regression. We can get the fit line for all of these together, right? So here the same thing. You click the Control, or I don't remember for the MacBook you hold the button Command, right? Okay, and then hold that button, hold Control, all right, and then click this right triangle, Customize Summary Statistics. That means here are all the options that you can ask the jump to show for each variable, right? So the one I want to show is number of missing values, right? So that would be n missing, right? And then click OK. So then that means all the variables will show, okay, this variable has 0 missing values. This variable has 0. This one has 3 missing values, right? And then this one has 1. This one has 1. This one has 1, right? And then this is a category, last one is a categorical variable with 0 missing, right? So then this question is asking about how many input variables have missing observations, right? So be careful. This question is not asking about how many missing values. Here I'm asking about how many input variables have missing observations. All right, so even though you have missing values here, the decision tree, the magic of the decision tree is it can deal with the missing values, so you don't need to worry about that. Here, I just ask you about how many input variables have missing observations. All right, okay, and then next question is an easy question, right? So how many levels does the variable building type contain? All right, okay, and then number 3 is a multiple choice questions. You can just try to get that by yourselves. Number 4, I want you to construct a classification tree using this variable as the response, right? So of course this variable will be a categorical variable, right? And then here I need you to include the split counts in your output, right? And also I need you to show me the whole tree, split history, and column contribution table together as a picture, right? If you still remember how to save the output, all right, and then export as the image, and then you can upload here. All right, and then based on the classification tree you got, right, I want to know how many houses are used in the training set. All right, and then based on the same output, I want to count how many terminal nodes. So here, and that means the end nodes, right? How many end nodes are there? So actually, you need to count how many subgroups has no more subgroups, right? So that would be the end nodes. And here, Number 7, what variables are used in the model, right? So here is the hint, right? You need to look at the column contribution table to see which variables are really used. All right, and then number 8 is find the characteristics of a houses most likely to sell above this amount, right? So remember, this is a categorical variable, right? So how to describe the characteristics about these houses, right? So here, actually give you a hint, right? Use the terminal nodes with the most yeses, right? So if you still remember, we used the counts to describe the characteristics, right? Okay, and then where is it? Okay, and then number 9. Next, I want you to construct a regression tree. Use the sale price as the response, right? So we say if the response variable is a quantitative variable, then we call this is the regression tree. All right. Okay. Now I want you to create a regression tree using a using a quantitative response variable. All right, and then the same thing. Be sure to include the validation into validation so that you know where to stop, right? Again, I need you to show me the whole tree, split history, and column contribution table as a PNG file, image file, right? And then upload here. Okay, and then number 10, use your regression tree model and then make the prediction for the following house, right? So you just follow the tree, and then here this is the description about this house. So that will include all the information you need until you have the end nodes, and then you just make the prediction about this house based on the regression tree. All right, and then number 11 is a little bit different, right? So here, number 11, I want you to fit a multiple linear regression model by using this analyze fit model option, right? Just like what you did in the project 2. Right, and then with the variables used as inputs in the regression tree, right? So remember in the last question here, you have a regression tree with the column contribution table, right? So then from the column contribution table, of course, you can know which variables are used, which one is not, right? So then here I want you to create a model with the variables are really used in the regression tree, and then based on the outputs, you can write out the regression equation, right? Just like what you did in the project 2. And then based on the equation, you plug in the numbers into the equation so that you can calculate the predictions, right? So then here, I want you to input your prediction for this house, the detailed prediction, right? Based on the multiple regression. Right, not the regression tree, right, based on the multiple regression equation, right? And then now you have 2 predictions. One is based on the regression tree, one is based on the multiple linear regression. And then I want you to compare which one has a more accurate prediction, right? So actually in here you have the real sale price, right? The actual sale price, right? So then I want you to choose which one is more accurate. That means which one has smaller residual. All right. Okay, so that will be all you need to do for the decision tree part. All right, and I think these questions are quite straightforward for you, and you just have one trial, right? You have 2 trials, but after each trial, you cannot see your correct or you cannot see your answers, of course, and you don't know which one you got correct, which one you got wrong, because I don't want everyone to share your answers with each other, right? So just think about which question can be wrong and then try to check them. Right, so even though this is a quiz, right, you don't have time limit, right, you just have 2 trials. So whenever you are ready to submit, then you submit. If you submit, that will be counted as one trial. All right. Okay, so then that's it for today's class, and happy holiday. Right. Bye, guys.